Welcome to educational channel. So this video I'll explain you about quadrilaterals for class 8 ICSE board. The complete information about this chapter I'll explain now. So it's very important topic. So each and every concept in this. So and about theorems, how to prove, and based on the theorems how to solve the numerical problems also. I'll explain you one by one. And before going this chapter, so let me show you a website here. You can see the link in description below also. So if you go through this, you can find out some model test papers and question bank, and this chapter, particular all the chapters, assignment papers, including solution sets also are available. So you can go through this channel, and along with that, you can find out more information. And subscribe the channel because we'll upload only the videos which are related to education. So it's useful for you and as well as your friends. Fine. Now, so let's see the topic now. So quadrilaterals. So when you see it's a quad, right? So 4. Triangle means it's a 3. Tri. So it's a quad is 4. Quadrilaterals. So there's a 4 lateral surfaces. Lateral sides. That means a closed figure bounded by 4 line segments. So if you take 4 line segment, so for example 1, 2, 3, I have taken 4 like this. So this is not a quadrilateral shape. A closed figure bounded by 4 line segments is called quadrilaterals. So 4 sides. So when you take anything, now this is 4 sides. So 4 lines if you take, so 1 and should be closed, 2, 3, 4. So closed figure bounded by 4 line segments, and there must line segment is a endpoint. There should be endpoints. Now you can keep a vertex A, B, C and D, and this is one of the quadrilateral. Taking PQRS. Now according to the shapes and sizes of that, we have the different names of quadrilaterals: square, rectangle, trapezium, rhombus. So they're all I will show you now one by one. First of all, quadrilateral. It is a closed figure. That means, for example, if you take ABCD is a quadrilateral, it has 4 vertices, and PQRS is a quadrilateral. It has the 4 vertices. So every quadrilateral has 4 vertices. Now if you see this example, A, B and C, D are the 4 vertices and 4 sides. So you see one by one. So first of all, it's a closed figure. It's having 4 sides, 4 line segments. Okay, so taking one shape. So 1, 2, 3, 4. An important thing, whenever you're writing the vertices names with the capital letters, you should go in order, either clockwise or anti-clockwise. So if I write A and B and C should be here only, it should not be C here, it's not right. So either clockwise or anti-clockwise only we need to write. You can start any vertex anywhere. The letter we need to start in order, A, B, C, D. So any order, either clockwise or anti-clockwise, then only we can say this. So this one we have 4 vertices. So 4 vertices here, capital A, B, C, D, and every quadrilateral has 4 sides because the 4 sides closed figure. So in this figure, the AB, B to C and C to D, so CD and AD. Okay, these 4 sides. So because of line segments, I am keeping line segment symbol on top. And 4 angles. 4 angles. That is angle A, angle B, angle C and angle D. So when you see this angle A, this is nothing but DAB or BAD. So this is same, either D to A and A to B. So DAB or BAD. So that is nothing but angle A. And 2 diagonals. So if you observe here, there are 2 diagonal. So diagonals means joining with line segment opposite vertices. Now I may join this A to C and D to B. So two diagonals, that is AC and BD. AC and BD. The two diagonals simply intersect at one point. So any quadrilateral, if you draw the two diagonals, two opposite vertices if you join, the two line segments will join at one point. Okay, this is a brief information about quadrilaterals. Now we'll see what is adjacent sides, opposite sides, and adjacent angle and opposite angles as well as. So let me take another quadrilateral. Say we can take anything. So it's a four line segments. So 1, 2, 3, and 4, and it forms two diagonals joining the opposite vertices. So take let us A B C D, starting A. If I start with B, I'm writing now anti-clockwise. So AB, then must be C here, then it should be D, then it's correct. Okay, the common point. Now what is adjacent sides? Adjacent sides and adjacent angles, opposite sides and opposite angles I'll explain now. First we'll see what is adjacent side. So when you observe here, two sides of a quadrilateral having a common endpoint, right? So now AB and AD, A is the common. So and common endpoint are called nothing but adjacent or consecutive sides. Now AB and AD, A is the common point. So AB and AD are the adjacent sides. And in this AB and BC also adjacent sides, and BC and CD are adjacent sides. So when they have the common point, so common vertex. So here AB, BC, these both are adjacent to each other. Similarly, BC and CD, and similarly CD and AD, because these are the common vertex. At the same time, A is the common vertex as BA and AD. Okay. These are the adjacent sides. So two sides of a quadrilateral having a common endpoint are called adjacent sides. There should be common endpoint. A is a common endpoint for AB and AD. Like similarly, C is the common endpoint for BC and CD. So BC and CD are the adjacent sides. Right? Now opposite sides. So when you see opposite sides, in the meaning, it's the word itself shows its meaning. Two sides of quadrilateral having no common endpoint. Okay, then only we can call it as the opposite sides. No common endpoint. So when you observe, for AD line segment, BC line segment, there is no any common endpoint. Then only we can say AD and BC are the opposite sides. That's in only quadrilateral, not all the shapes. Here AD, BC are the opposite sides, and CD is a one line segment, and AB is a line segment. There is no any common endpoint. Then you can say that they are the opposite sides. So in this given quadrilateral, AB, CD and BC and AD are the two pairs of its opposite sides. Right? Now adjacent angles. So this is about adjacent sides and opposite sides. Now when you see adjacent angles, adjacent angles, similarly opposite angles. So what is adjacent angle and what is opposite angle in quadrilateral LC? So two angles are quadrilateral having the common arm. So when you let me take one quadrilateral. Okay, taking one rectangle. So this is a quadrilateral, four sides, a closed bounded figure. So taking names A, B, C, D. Adjacent angle. Two angles of quadrilateral having a common arm are called adjacent or consecutive angles. So here angle A and angle D, right? So for A is nothing but DAB and D is nothing but ADC. So AD is a common arm for both. So when you see angle A, this is angle A, and from D, this is the angle D. So AD is the common for both. So angle A and angle D are the adjacent sides, adjacent angles. Angle A and angle D. Common arm should be again similarly angle A and angle B, because AB is the common, and angle B, angle C are the adjacent angles, and angle C and angle D are the adjacent angles. So only one thing is common arm. So they should have common arm. So common side. Now when you see the opposite angles, two angles of quadrant have not having any common arm. So not having any common. We can call them opposite angles. So in this given quadrilateral, angle A and C. So A is A and C. These both are opposite. Angle A and angle C. So this is not having any common arm. So common side. For A is just DAB and C is DCB this side. Similarly, other opposite angle is angle D and angle B. And this is one pair, and angle B, angle D also common opposite angles because they don't have any common arms, right? So this is about adjacent angles and opposite angles. Similarly, adjacent sides and opposite sides, and every quadrilateral having these are the basic important properties you should have. And we'll see some other important results on these quadrilaterals apart from these basics. So let me explain some other important results on these quadrilaterals, including theorems. The sum of all the angles of a quadrilateral is 360 degree. So let me prove this theorem, and based on this theorem, based on this statement, we can prove some problems also, how the questions will come based on this concept, like sum of all the angles of a quadrilateral is 360. So first I will prove this theorem, then using that theorem only I will show some examples how the questions will come and we need to solve them, right? So here theorem is statement is sum of all the angles of a quadrilateral is 360 degree. Now when you see the given data, so given data is this, we need to prove. So let me take one quadrilateral, four angles. The four angles if I add, it should be equal to 360 degree. That is sum of all the angles of a quadrilateral is 360. So A, B, C, D, A, B, C and D are the vertices of this quadrilateral. So it's a given. So given data is a quadrilateral ABCD. So just only given quadrilateral ABCD. So it's given. Now we need to prove. So required to prove. So we have to prove there is angle A plus angle B plus angle C and angle D is equals to 360 degree. So this we need to require to prove. And we need to do some small construction here because to prove the theorem. So construction, So we need to join any one of the, we need to draw a diagonal. So that is, so take a line. So I am joining the vertices B and D. Then there are two triangles, because theorem concept is from triangles. So we know sum of the angles in a triangle is 180 degree. So using that we will prove this. So here construction is join B to D. So that we did joining. Yes, let's see the proof now. So you know that sum of the angles of a triangle is 180 degree, right? So in any triangle, the sum of the angles of a triangle is 180 degree. That we know it. So sum of angle. So sum of the angles in a triangle. In a triangle is equals to 180 degree. So when you see here, there are two triangles. Triangle ADB and triangle CDB. So let me take the letters, this angle number 1, 2, and it is 3 and 4. Because angle B means 1 plus 3. Angle D is here 2 plus 4. So angle 2 and 2 and 4. Therefore, using this, first from triangle ABD. Okay, from triangle ABD. From ABD triangle, angle A plus and angle 1 plus angle 2 is equals to 180 degrees, right? We know it. And similarly, from other side one is BCD. Okay, from BCD, again angle C plus angle 3 plus angle 4 is equals to 180 degrees. And when you do adding of this both equations, like this, let be first equation and second. So 1 and 2 equations I am adding. So that implies LHS and RHS we need to add separately. Angle A plus angle C plus 1 plus 3. Angle 1 plus angle 3 and angle 2 plus angle 4 is equals to 180 plus 180 is 360 degree. Right? Yes. Now 1 plus 3. So angle A plus angle C as it is, and angle 1 plus 3 is nothing but this is one of the angle in that. So angle 1 plus 3, if you observe, there is angle B, and 2 plus 4 is angle 2 plus 4 is angle D. 1 plus this is B, plus instead of this we can write angle B plus again angle 2 plus 4. So you can observe here these both, instead of angle this both we can write angle D, because angle 2 and 4 is 360 degrees. That's it. Therefore we can write angle A plus B plus C plus D. Sum of the four angles in a quadrilateral is 360 degrees, right? So 1 plus 3 is B, and this 1 plus 3 is B, and 2 plus 4 is D. That only we are taken. We need to take separate triangle just to do the adding of two equations. We will get sum of the four angles of a quadrilateral is 360 degree. Fine. So using this statement, so the questions will come. So let me show you. And if they give any three angles, we can find out the other one. So for example, problem 1. Three angles of a quadrilateral ABCD. Three angles of a quadrilateral ABCD are angle A 70 degree, angle B 50 degrees, and angle C is given 82 degree, right? Then find angle D. Find angle D is equals to dash. So this is in quadrilateral ABCD. So here ABCD is 360 degrees, just to prove. So these four angles, if you add, it should be equal to 360 degree. A plus B plus C plus D. So same theorem. So same theorem if you apply. Sum of the angles in a quadrilateral is 360 degrees. Therefore, angle A plus B plus C plus D is equals to 360 degree. So here A is given 70 plus B is 50 and C is 82. Angle D we don't know, we need to find out, write as it is. Then these three if you add 70 plus 50, okay, 120 plus 82, 202 plus angle D is 360 degrees. Then angle D is equal to 360 minus 202. You can subtract both, that is 158 degrees. Therefore, angle D is 158 degrees. So this is a simple question. If we tell you any three angles, we can find out the fourth angle. Fine. Let me show you one numeric word problems also in this. For example, the angles of a quadrilateral. The angles of a quadrilateral are in the ratio. So 2:3:7:6. Four angles are in the ratio 2:3:7:6. Right? Then find the measures of each angle of the quadrilateral. Fine. So this is a given question. So using the same concept, let me show you this solution. Right. The angles of a quadrilateral is, we know sum of the angles in a quadrilateral is 360 degree. So whenever it is 360 degree, we can, this is the ratio 2:3:7:6. Then let the angles are 2x, 3x, 7x and 6x you can take, because this is given ratio, not angle. So let 2x, 3x, 7x, 6x, and according to the property, the property is sum of all angles in a quadrilateral is equals to 360 degree. So sum of all angles in quadrilaterals here, 2x plus 3x plus 7x plus 6x is equals to 360 degrees. Right? Then we can add this solve, that is this 2 plus 3 is 5 plus 7, 12 plus 6 is 18. So 18x is equal to 360 degree. Then x is equals to 360 by 18. So that is 18 2s, 18 1s, 18 2s, 36, 20. So x is equals to 20. X value is 20. Once you know x value, you can find out these angles. So whatever they required. So 2x, 3x, 7x and 6x are the four angles. Then angles, therefore first angle is 2, ratio is 2, so 2x, that is 2 into 20, so 40 degrees. And similarly second angle is 3x, so 3 into 20, that is 60 degree. And third angle is 7x, right? So 7 into 20, so 140 degrees. And similarly last is given 6x. So fourth angle is 6x, so 6 into 20, so it's 120. And for verification you can do this, if you add all this you will get again 360 degrees also. This is only for verification. So we can find out in this. And let me show one more. This is about ratio. So like ratio type the question is given, we can solve in this using the same property. And for example, So here, and the angles of a quadrilateral in terms of x if they are given. So how to do? So angles, the angles of a quadrilateral are 5x comma 5 of x plus 2 and 6x minus 20 and 6 of x plus 3. So if the four angles are like this, then we need to find out the angle. So here first question is the value of x. Okay, find the value of x and find angles. So this is in quadrilateral. This 5x, 5 of x plus 2, 6x minus 20, 6 of x plus 3. So we know that the sum of angles of a quadrilateral is 360, right? Sum of angles in a quadrilateral is 360. Therefore, we can add these four angles, that is 5x plus 5 of x plus 2 plus 6x minus 20 plus 6 of x plus 3 is equals to 360 degree. Then if you simplify this, you'll get the angles. So you can simplify this. 5x plus 5 into x is 5x plus 5 2 is 10. So you should multiply like this individually. Plus 6x minus 20 plus 6x plus 6 into 3 is 18 is equals to 360 degree. You can add all the x terms. 5x plus 6x plus 6. 6 plus 6 is 12 and 12 plus this 5 plus 5 10 22. So all the x terms you add, so 22x. And numbers plus 10 minus 20 is minus 10 plus 18, so plus 8 is equal to 360. Then 22x is equals to 360 minus 8, so 352. Then you can find out the value of x. Therefore x is equals to 352 divided by 22. So 22 you can cancel with 11 table. 11 2s are 22, 11 3s are 33, and 2 carry 2s are 2 1s are 216. So just do simplification. So x is equal to 16. Therefore x is equal to 16. Once you know x value, you can substitute this x value in that first, second, third, fourth angles. Then you can find out. Right? When you see this, yes. So angles are 5x. First angle is 5x. So 5 into 16. So 80 degree. And this is first angle. And second angle is 5 of x plus 2. So 5 into 16 plus 2. 16 plus 2 is 18. 18 5 is 90. And third angle is 6x minus 20. That is 6 into 16 minus 20. That is 76 overall. And the fourth angle is 6 of x plus 3, right? So 6 into 16 plus 3, that is 6 into 19. So 19 6 is 114. They are the four angles. You can add this 4 to verification purpose. So automatically all 80 plus 90 plus 76 plus 114, you will get again 360 degrees. So like this you will get the problems based on this sum of all the angles of a quadrilateral is 360. So using the theorem we can prove. Okay, this is a simple thing. And next we will see various types of quadrilaterals. So in quadrilaterals there are many types. So we know already few name of them, right? Parallelogram and trapezium, rectangle, square, rhombus. So there are 5 types. So that various types of quadrilaterals and their properties. So I'll explain you now. So parallelogram and its properties. So we'll see first of all what is parallelogram and what are the properties it has. So how to define the parallelogram? So a quadrilateral, because we learn about quadrilateral, a quadrilateral in which both pairs of opposite sides, both pairs, right? Both pairs of opposite sides both pairs of opposite sides are parallel is called parallelogram. So here both pairs of opposite sides. So when we see, this is important, both pairs of opposite sides are parallel. So let us take the diagram about this. Every quadrilateral has four sides. Now here both pairs of opposite sides are parallel. Now this is one side and its opposite side. So these both must be parallel to each other. And other two, if you take, and this is one more pair, and they are parallel, right? So A, B, C, D. Take the letters. Vertices is A, B and C, D. So AB side is parallel to CD and AD side is parallel to BC. So we can use the symbols for parallelogram. Single arrow, if we keep the same arrow mark, that means AB and CD are parallel, and AD, BC are also parallel. If we keep double arrows symbols on top, so these both sides are parallel, right? In this figure, ABCD is a quadrilateral in which AB and CD are parallel, AD and BC are other two sides are parallel. Therefore, ABCD is a parallelogram. Now let us see the properties of parallelogram. In case according to these properties, how we can write the properties of this. So we'll see first one. In a parallelogram, so here is its A, B, C, D. So you can take any letters P, Q, R, S, right? So in this example, I took A, B, C, D. Now join with the diagonals also. Join with lines. AC is a diagonal and BD is a diagonal. Diagonals are intersecting at point O. Okay, see, let us see the properties one by one. So first property is opposite sides are parallel. That's it. That is from the statement only. Opposite sides are parallel. So here opposite sides are AB and CD. That is AB is, this is parallel symbol. AB is parallel to DC and AD is parallel to BC. And second one, just I'll explain only properties one by one. First one is opposite sides are parallel, and next one is opposite sides are equal in this parallelogram. Opposite sides are equal. So they are parallel as well as they must be equal also. That is, you can write AB is equals to DC. The opposite sides are equal. Then AD is parallel to BC and AD is parallel. AD is equals to BC also. These opposite sides are equal. And opposite angles are equal in this parallelogram. Opposite angles. opposite angles are equal. So if you see the opposite angles, angle A is equals to angle C, because A and C are opposite. You already learned what is opposite adjacent, and angle B is opposite to angle D. So they both are equal. A, C are equal and B and D also equal. And next, adjacent angles are supplementary in this parallelogram. So adjacent angles are supplementary. Supplementary is nothing but sum of the two angles are 180 degrees supplementary. You know already. And sum of the two angles is 90, that is complementary. So here adjacent angles are supplementary. So adjacent angles are nothing but A, B. So when you observe, A and B are adjacent, and B, C are adjacent, C, D are adjacent, and A, D are adjacent. So adjacent angles are supplementary. That means if you add them, like angle A plus B is equals to 180 degree. Again angle B plus C is 180 degrees. Again angle C plus D is 180 degree. Similarly angle D plus A is 180 degree. So four pair of adjacent angles, they are supplementary. And diagonals bisect each other in this. If you observe the diagram, AC is one diagonal, BD is one diagonal, they bisect each other. So bisect means from center. For example, if you see here, distance from A to O and O to C both are equal, and BO and OD is equal. So they bisect each other. So perpendicular bisect each other is different, and bisect each other here. So the diagonals bisect each other. That is OA, because O is center point, intersecting point. OA to OC is equal. Similarly OB and OD are equal, and each diagonal bisect the parallelogram. So each and every diagonal the bisect the parallelogram is divided into two congruent triangles. You know it. So each diagonal it bisect the parallelogram. Okay. That is also property. So 6 properties it has, and the last one is each diagonal bisect the parallelogram. So when we observe, so if this is a parallelogram and taken one diagonal, okay, if you take the diagonal is any diagonal, so this diagonal it divides in this total parallelogram two exactly equal parts, that is bisect the parallelogram. So this one and other one is both are same. For example, if A, B, C, D, AC is the diagonal, then triangle ABC is exactly congruent to triangle ADC. Right? And similarly other one if you take like this, and ABD and BDC, okay, other side. So each and every diagonal, there are two diagonals, so each diagonal bisect the parallelogram. That means divided into two congruent triangles. Okay, they both are congruent, means similar shape and size. Each diagonal bisect the parallelogram. If you take the BD, then ABD and BDC also equal. Okay, and similarly triangle ABD. ABD is congruent to BDC or DBC. Okay, you can see this. So these are the important properties, 6 properties you can use. Mostly opposite sides are Opposite sides are parallel, opposite sides are equal, opposite angles are equal, and adjacent angles are supplementary. Diagonals bisect each other. Similarly, each diagonal also bisect the parallelogram. Okay, these 6 properties, including definition, you can see like this. And next, I'll explain you. This is about parallelogram and its properties. Next, you'll see what is triangle. So, what is rectangle? Rectangle definition and its properties also. Let's see now. Rectangle and its properties. So we'll see what is exactly rectangle and its definition. Then let me show you some properties of this rectangle also. Right. So a parallelogram, each of the angle, if any parallelogram, if each angle is measures 90 degrees, then it's a rectangle. So rectangle definition will come from the parallelogram. So let me write here. A parallelogram each of whose angles measures 90 degrees is called a rectangle. So when you compare this rectangle, it will come from actually from parallelogram. So it's 90 degrees. So we have seen the properties of parallelogram in previous. Now parallelogram in each whose angle measures is 90 degrees is called rectangle. So see the diagram. So A, B, C, D are vertices. So ABC is a rectangle now. So each and every angle is 90 degrees. That means AB is perpendicular to AD and AD is perpendicular to DC. Similarly, this is. So each and every angle is 90 degrees. Right? There's a right angle symbol. So every angle is right angle. Now see the properties. So in a rectangle ABCD, the first property is opposite sides are equal. Opposite sides are equal. So when opposite sides are equal, that is we have two pair of opposites. That is AB is equals to CD and AD is equals to BC. Okay, these two. AB is equal to CD and AD is equals to BC. And each angle measures 90 degrees. Same from the definition, the properties, each angle. Opposite sides are equal and each angle measures 90 degrees. That is angle A is equals to angle B and is equals to angle C and that is equals to D, and every angle is 90 degrees. So you can write like this. And diagonals are equal. So in the important property in the rectangle is diagonals are equal here. Diagonals are equal. So in parallelogram, diagonals are not equal, right? But in rectangle, diagonals are equal. So if you see the diagonal, AC is one diagonal and DB. There are two diagonals. They are intersecting at point O. So diagonals are equal. So when diagonals are equal, you can write AC is equals to BD. These diagonals are equal. And when diagonals are equal, the diagonals bisect each other here. Same like parallelogram and these properties. Diagonals bisect each other. So that means O is the intersecting point. So O to A and OC are equal. So OA is equals to OC and O is the intersecting point, right? So OB is equals to OD. So this is diagonals bisect each other. So they're not perpendicular bisect each other, it's only bisect each other. So these are the four properties you can use for rectangle. Opposite sides are equal and each and every angle is 90 degrees. And diagonals are equal as well as diagonals are bisecting each other. And from parallelogram only whose angles measures 90 is a rectangle. And similarly we'll see the square. So the square definition and its properties also we'll see now. Square and its properties. So how we can define the square? So let's see here. A rectangle. So square definition will come from rectangle. Because rectangle definition we are taken from the parallelogram. So a rectangle. So you have seen already properties of rectangle. A rectangle having all sides. A rectangle having all sides equal. So rectangle having all sides. If every side is equal, then only we can call it as square. So all sides equal is called a square. Yeah. So this way you can define. Now let me take the square diagram. So generally all sides must be equal. So if it is a square, vertex A, B, C and D. Now let me explain the properties of this. So in this opposite sides, so same actually whatever the properties are there in rectangle, same will follow. So since opposite sides are equal, so here all the sides are equal. That means same other properties. So AB is equals to AB, BC and CD and AD. So four sides are equal. And same if two adjacent sides of rectangle are equal also, then it's called a square, you can see. See the properties. Same properties from rectangle, so but extra one more property will add in the square. So let me show you that. So first one, all sides are equal, right? In a square is ABCD, all sides are equal. This is the first property. This is from the definition. All sides are equal. So that is, we can say AB is equals to BC is equals to CD is equals to DA, right? Yeah. Now each angle measures 90 degrees. So same property from rectangle is also. Each angle is equals to 90 degrees. So right angle each and everything. So every side is perpendicular to adjacent side. So every angle is 90 degrees. And diagonals are equal. In this also, diagonals are equal. So here diagonals are A to C, right? AC is a diagonal and BD is a diagonal. Two diagonals are equal and diagonals bisect each other. So in this square, diagonals are bisect each other. Same diagonals bisect each other. So if the common point is O, then OA is equals to OC and OB is equals to OD. And extra another property. These four properties we have seen already in our rectangle. And here diagonals intersect at right angles. Okay, diagonals intersect at right angle. That means when you observe this, so this AC and BD are intersecting at O. The intersecting angle is at 90 degrees. So that is a perpendicular bisectors. That means you can say them perpendicular bisectors. The angle is 90 degrees. So every angle, this also 90, this also 90 and this Angle AOB is 90, BOC is 90, similarly COD and AOD also is 90 degrees. So you can say diagonals intersect at right angles. That is AC is perpendicular to BD. This is a perpendicular symbol. So this is extra another property you can see in the square. All the sides are equal. Same properties. The diagonals are intersecting each other at the same time. They bisect each other. So that's why you can call it as a perpendicular bisectors. So diagonals of square are perpendicular bisectors. Right? These are the properties about a square. Next, after square, we'll see and properties of trapezium also now. Rhombus and its properties. So here we'll see the properties of rhombus and how we can take. So square properties we compare with rectangle, right? Similarly, rhombus properties we compare with parallelogram. So let me show you the definition first. A parallelogram. So from the parallelogram only we can take. Okay, a parallelogram having all sides equal is called rhombus. Okay, simple thing. Parallelogram having all sides are equal. So in parallelogram opposite sides are equal. In case the parallelogram all sides are equal, that will become as a rhombus. So this you can see as a definition. That means all the sides, for example, let me draw a rhombus here. All sides should be equal. So we can take, you should take the same distance. So here A, B, C, D, vertex A, B, C, T. So rhombus is one of the quadrilateral. So in this AB is equals to and BC is equals to CD and that is equals to DA. That means all the sides are equal. Then only you can say ABCD is a rhombus. So AB, BC, CD and DA. Parallelogram having all sides are equal is called rhombus. So let us see some properties of this rhombus also. So when you compare the properties, similarly we will compare the properties from the parallelogram. So in a rhombus ABCD, the first one you can say is opposite sides are parallel because we are taking the properties from parallelogram. So parallelogram also same. Opposite sides are parallel. Therefore rhombus also same opposite side. Opposite sides are parallel. So same distance between the two line segments. So nothing but they are parallel. So you can write here is AB is parallel to DC and AD is parallel to BC. This is a parallel symbol. And second one, when you verify here, yeah, all sides are equal. So this is from the definition because the parallelogram having all sides are equal. This is called rhombus. Therefore here also all sides are equal. So when all sides are equal, then we can say same. AB is equals to BC is equals to CD is equals to DA. So all the sides are equal. And the important thing when you come to diagonals, diagonals bisect each other at right angles. So this is also some property from the square if you observe. Diagonals bisect each other at right angles. Right, so diagonals, I am taking two diagonals. So every quadrant is having two diagonals. So joining of the opposite vertices AC and BD. Okay, these two are the diagonals. Then intersected right angles. So that means this angle is 90 degrees. If the intersecting is point at O, then same, they bisect each other at right angles. And diagonals bisect the angles of rhombus also. So angle AOB is 90 and BOC is 90, COD is 90. Similarly, DOA also 90 degrees. So AO, here is an diagonals also equal. Sorry, in diagonals are not equal. That means only AO. They intersect each other. So A to O and O to C is equal. And O to B and O to D is equal. And in rhombus, so diagonals are not equal actually here. And diagonals bisect the angles of the rhombus. So diagonals also will bisect the angle of the rhombus. That means AC bisect angle A and C. And BD bisect angle B and D. So BD is bisecting angle B and D. Bisecting means it make into half. So this is an important property. See here. So angle, these two angles, if it is x degree, and this also should be must be x, and this two also should be same. So AC bisect angle A and C. Similarly, BD also bisect angle B and D. So diagonals, so we can write like this: diagonals bisect the angle so they bisect the angles of the rhombus, right? Therefore we can say that is AC is one of the diagonal, right? So it bisects angle A and angle C. That means it make into two equal parts. There is a bisecting. Like if it is a 60 degree, divide into 38 degree and 30 degree. Similarly, BD is another diagonal. It bisects angle B and angle D, right? Then this will, if it is totally 60 degree, means if it becomes 30 and 30. So equal values you get in both places. So in this way they will bisect it. So these are the properties of rhombus. A parallelogram, so you take only from parallelogram, having all sides are equal, is called rhombus, right? Next we have more quadrilaterals. Next we will see properties of trapezium and its definitions also. Trapezium and its properties. So let me explain you the definition, how we can define the trapezium, right? So in quadrilateral, so one type of quadrilateral is trapezium. Therefore, we can write like this: a quadrilateral in which one pair. So I will show you a diagram also. So one pair of opposite sides. One pair of opposite sides is parallel. Is called a trapezium. So when you see this, in any quadrilateral only one pair of opposite sides is parallel. So only one pair I need to draw parallel lines. So we can draw the parallelogram like this. So one pair. So I am taking. So these two are parallel lines and other two are non-parallel. So vertex A, B, C and D. Here AB is parallel to CD. So one pair is parallel. Then in this figure ABCD is a quadrilateral in which AB is parallel to CD. So according to definition, ABCD is a trapezium, right? And the non-parallel sides are the right remaining AD and BC. These non-parallel sides of trapezium are called oblique side. So AD and BC, we can call them oblique. OBLIQE. So other sides means non-parallel sides, so we can call as oblique sides. They are AD and BC in this. And when you see the properties of this trapezium, so there are two important properties. The first one is one pair of opposite sides is parallel. So that is according to the definition. You know what? That is okay. So let me write the properties also here. One pair of opposite sides. One pair of opposite sides is parallel. So here AB is parallel to CD, right? And when you see the one more, so two pairs of adjacent angles or supplementary. Two pairs of adjacent angles. Here, if AB is parallel to CD and angle A and D, so this is one pair. So there we have 1, 2, 3, 4, 5, 6. Total we have 4 pairs. Only and C and B. Angle B plus C also. For example, I am taking 1, 2. This is 3, 4. So angle 1 and plus angle 2 must be 180 degrees. So they are supplementary. So this is an important property. The two pairs. So two pairs of adjacent angles that are which form only pairs of consecutive interior angles. So consecutive interior angles, because when the two lines are parallel, one is transversal. Here AB is parallel to CD and AD is transversal. So they are one side, which form the pair of consecutive interior angles. And then we can say two pairs of adjacent angles or supplementary. Then we can say that is angle A plus angle D is equals to 180 degrees, and angle B plus angle C is also 180 degrees. So according to these property, we can solve some problems. If they give angle A, we can find out angle D, because the two lines are parallel and one more is transversal. So we can see in this any way also. For example, two lines are parallel and transversal. Then these two are same side of the transversal. So these two must be 180 degrees. So if we take A and D are 180 degrees. So this is the property we can apply. And when you see, this is a trapezium. One pair is parallel, we know that. In case the non-parallel sides of the equal, so these oblique sides, if they are equal, we can call them as you see here, isosceles trapezium. If the two non-parallel sides of trapezium are equal, then it's known as isosceles trapezium. So let me draw a diagram. We should take two parallel sides and other non-parallel should be equal distance, equal measure. Yes. So AB, CD. So isosceles trapezium means one pair. If it is parallel, it's a trapezium, and non-parallel sides are equal. That means AD is equals to BC. Here AB is parallel to CD and AD is equals to BC. Non-parallel side, that is oblique sides are equal. Therefore, then ABCD is, we can call it as a isosceles trapezium, right? Okay. Now let me explain some properties also in this. So in any isosceles trapezium, so one pair of opposite sides are parallel, you know it. So we'll see the properties one by one, because we need to apply this concept in the problems. One pair of opposite sides. one pair of opposite sides is parallel. Same like from trapezium, that is here AB is parallel to CD, and two pairs of adjacent angles forms the interior angles. This is supplementary, same second property as it is. And third one, angles on the same base are equal. So this is second property, same like this. First and second properties are same. Now directly I am writing the third one. Angles on the same base are equal. Angles on the same base are equal. So here same base is angle A and angle B. So these both are equal. At the same time, angles D and angle C also equal, right? So angle A is equals to angle B, or on the same base, only on parallel, and angle C is equals to angle D. And one more property same, because adjacent sum of these angles, so 180 degrees, you know it. There is angle A plus D. There is angle A plus angle D is equals to 180 degrees. They are supplementary. Angle B plus angle C is equals to 180 degrees, supplementary. Everything is same from this data. First and second properties are same. When you come to isosceles trapezium, and angles on the same base are equal, right? If A is, if it is 60 degree, and B also should be 60, right? And this is obviously 120, and this also is 120. Angle C also 120. Same rule. Angle A plus D is 180 and B plus C 180. Similarly, angles on the same base are equal. Okay, these properties we'll see for isosceles trapezium. And one of the quadrilateral is the kite. So kite diagram and its properties also I'll explain you now. Kite and its properties. So kite is one of the quadrilateral. So let me write the definition here. A quadrilateral in which two pairs of adjacent sides are equal. So I'll explain the diagram. So in any quadrilateral, two pairs of adjacent. So adjacent sides are equal. So already learn about adjacents. Then is known as a kite. Is known as a kite. So this we can take it as a definition. So a quadrilateral in which two pairs of adjacent sides are equal is known as kite. So here two pairs of adjacent sides. So when you take the letters, so I'm taking A, B, C, D. So here only two pair of adjacent sides. So AB and AD are equal, and BC and DC are equal. So these are the two pair. Then only we can say ABCD is a kite. So when you see the properties one by one, first property is two pairs of adjacent sides are equal. So that is from the definition. So two pairs of adjacent sides are equal means that is AB is equals to AD and BC is equals to CD. Okay, this is from the property 1. This is from definition. Then one pair of opposite angles is equal. So one pair of opposite angles. That means angle B is equals to D. Only one pair. One pair of opposite angles is equal. Angle B, angle D is a pair. So one pair of opposite angles is equal. So angle B is equals to angle D. Only one pair, so don't get confused about this. Only one pair, not exactly opposite pairs, opposite angles. So that's different. Now when you come to the kite, only one pair of opposite angles is equal. And diagonals intersect each other at right angles. That is okay. And diagonals intersect each other at right angles. So when you draw the diagonals AC and BD. So these two diagonals intersect each other at right angles. Then we can write AC is perpendicular to BD. Okay, because this is the intersecting point, this is 90 degrees. And one of the diagonals bisect by other. OB is equals to OD. Only one of the diagonal. So OB is equals to OD. Because angle B is equals to D, so OB is equals to OD. Because only one of the diagonals bisect by other, not both. And one of the diagonals bisect two opposite angles of the kites. That means AC bisect angle A and angle C. So one of the diagonals bisect the opposite angles of the kites. So here only one. If these two are equal and these two. So need not be always only angle B is equal to D. Sometimes A equal to C also, but only one pair. Similarly, this fourth property also only one of the diagonals bisect each other. This is only one of the diagonals bisect each other, and one of the diagonals bisect opposite angles, and one of the diagonals bisect the kite, divided into two congruent triangles. So only one means not two. So one of the diagonals bisect the kite, that is divided into two congruent triangles. So a diagonal AC is bisecting. If AC is bisecting means we can divide into two congruent triangles, that is ABC and ADC. Okay, because of AC is bisecting, AC bisects the kite, so then you can say triangle ABC is congruent to triangle ADC. Okay, ABC and ADC. ABC is this left side and ADC is the right. So they are congruent triangles. So all the properties you observe, only one of the diagonals will bisect, and one of the diagonal will bisect and the particular angles, and one of the diagonal bisect the kite. So only one of them. These are the important properties you remember for the kite. And based on these properties, so diagonal properties like a square, rectangle, rhombus, trapezium, and we can do various theorems also. So let us see one by one theorems using these properties how we can solve. Opposite sides in a parallelogram are equal. So in this theorem, I'll explain you how to prove opposite sides in a parallelogram are equal, right? So first of all, your given data is, so given information in a parallelogram ABCD. So this is the parallelogram. So vertex A, B, C and D. So according to the properties of parallelogram, the opposite sides are parallel, right? So there is a given data. So we can take the stepwise. Parallelogram ABCD. ABCD, in which AB is parallel to CD and other pair. So this is AD is parallel to BC, right? So when you see AB is parallel to CD and AD is parallel to BC. Okay. So this is the given data. Now we need to prove. So we have to required to prove is here. So we have to prove opposite sides in a parallelogram are equal. So opposite sides here AB is equals to CD and AD is equals to BC. Okay, these opposite sides are equal. I need to prove. And some small construction we need to do here, because actually this concept of this proving opposite sides in a parallelogram based on the congruency rule. So we will prove two triangles in congruent, then we'll prove the theorem. So your construction is, because it's only single parallelogram, if I join one diagonal, join A to C, so A and C I'm joining, then it forms two triangles. So observe here, from A to C. So AC is joined. Now ABC is a triangle and ACD is another triangle. So this is the construction joining A and C. Then we can prove a proof. This is what we need to prove. So this is a starting the proof now. So opposite sides in a parallelogram are equal, we need to prove, right? So when you compare these two triangles, if I prove ABC is a triangle and ACD triangle both are congruent, then corresponding sides are equal. That means AB equals to CD. Okay, here, yeah, AB equal to DC and BC equals to AD. That means I need to prove first of all ABC triangle and ADC triangle are congruent. Then according to CPCT, there is a corresponding parts of congruent triangle, we can conclude that opposite sides are equal. So before starting the proof, in triangle ABC and CDA, in triangle CDA. So from these both triangles we have angle. Okay, mention the angles. Here is two angles and here is two. So this is angle 1, 2, 3 and 4. So when you observe here, angle 1 and 2 are equal. So just to see, angle 1 and 2 are equal because AB is parallel to DC and AC is a transversal. So alternate angles. So because AB is parallel to DC and CA is a transversal. So alternate angles are equal. So angle 1 is equals to angle 2, that we can write. So angle 1 is equals to angle 2. So reason is alternate angles. Because AB is parallel to CD and CA is transversal. So that is a transversal, right? Okay. And similarly, other two like angle 4 and 3. That means angle 3 is equals to angle 4. This 3 and 4 also same alternate angles, but here AD is parallel to BC. So alternate angles. AD is parallel to BC. If AD is parallel to BC and same AC is a transversal. AC is a transversal. So AC or CA. This is a transversal, right? And one more thing is AC is a common side for both triangles. And AC is equals to AC. AC and CA. So both are same. We can write AC is equal to AC, or you can write A to C or C to A, both are same. AC is and CA. This is a common side, both triangles. Now two angles and side using these three. Therefore, triangle ABC is congruent to triangle CDA. That we can take ASA. So angle side angle axiom. So based on this angle side angle axiom, we can conclude that ABC is congruent to CDA. When two triangles are congruent, then according to CPCT, corresponding sides are equal. So we can conclude that since these two are congruent, then AB is equals to CD and BC is equals to AD. This is CPCT. So corresponding parts of congruent triangles. So you already studied in previous classes. So CPCT, corresponding parts of congruent triangle. So when two triangles are congruent, then corresponding parts are corresponding sides are in same ratio, but they are congruent, right? So they are equal. Then you can conclude AB is equal to CD and AD is equals to BC. Right? So we can prove in this. This is the theorem. So if you understand which two triangles you need to prove congruent, then it's very easy. Then how to prove the diagonals of parallelogram bisect each other? Also I'll explain now. The diagonals of parallelogram bisect each other. So this theorem I'll explain now. So how to prove diagonals of parallelogram bisect each other? So let's see here. So first of all, if you write the given data, so given information, here is a parallelogram ABCD. So I'm taking a parallelogram ABCD. So take the line. Opposite sides are parallel and opposite sides are equally. So when you take this and A, B, C, D, A is one vertex and B and C and D. So it gives two diagonals. So your first given data is according to this theorem, diagonals of parallelogram bisect each other. So AB is parallel to CD and AD is parallel to BC. We have to prove diagonals of parallelogram bisect each other. Okay. So your ABCD is a parallelogram. ABCD is a parallelogram and diagonals AC and BD intersect at O because AC is one diagonal and BD is other diagonal. So AC and BD intersect at O. Okay, that is we can draw here. That is AC is one diagonal and ABD is another diagonal. Now according to the given data, they intersect at O. Right. Now what we need to prove? So to prove, so diagonals of parallelogram bisect each other, and that means AC and BD. So we need to prove O to A because O is the intersecting point. OA is equals to OC and OB is equals to OD. This is the D. OAB is equals to OD. I need to prove same. So when you see the proof you observe. So we need to prove OA is equals to OB and OC is equals to, OB is equals to OD. Two triangles. If you observe this AOB, okay, this AOB triangle, and one more is DOC. These two triangles, if I prove congruent, then according to CPCT, I can confirm that OA is equals to OC and OB is equals to OD. That's it. So it's very simple. So in triangles OAB, so from the triangle OAB took one triangle and triangle OCD. So from these two triangles, you know that angle OAB. So if you observe, yeah, here this one, angle OAB and angle OCD is equal because AB is parallel to CD and AC is a transversal. So these two are equal. Then OAB angle is equals to OCD. So these two are alternate angles. Alternate angles. And similarly angle B, that is OBA. So we can observe that also. Take this OB. So this angle and ODC. These two angles also are equal. So when you take these two, same, AB is a parallel to CD and BD is a transversal. Okay, this BD is transversal. Then that we can write OBA. OBA is equals to ODC, angle ODC. These also same alternate angles. So when you try the condition, what purpose they are equal. And AB equal to CD, there is a parallelogram. AB is equal to CD because opposite sides are equal in a parallelogram. Opposite sides are equal in parallelogram, right? So here two angles and one side. Then according to angle, side, angle axiom, then we can say that triangle OAB is congruent to triangle OCD. Yes, so angle, side and angle, that is ASA axiom. So according to this axiom, these two are congruent. Hence, by CPCT we can say that OA is equals to OC and OB is equals to OD. This is a CPCT, corresponding parts of congruent triangle. Yes, so therefore we can conclude this. OA is equal to OC and OB is equals to OD. Simple. So therefore diagonals of parallelogram bisect each other. So we can prove in this. And if a pair of opposite sides of quadrilateral are equal or parallel in a parallelogram, so that theorem also I'll explain now. So this theorem is about if a pair of opposite sides of a quadrilateral are equal and parallel, then it is a parallelogram. So if only one pair of opposite sides are equal and parallel, we need to prove it is a parallelogram. So let's see this one. Here given information. So first we will write the given data, then we'll explain with the diagram. So given information is ABCD is a quadrilateral and only one pair. So let us take one quadrilateral, four sides, one pair. So this is equals to this side. So these two sides are equal and the two sides are parallel. We need to prove this is a parallelogram. See here. So ABCD. So ABCD is a quadrilateral and given is AB is equals to DC. AB is equals to DC and AB is parallel to DC. These two. So pair of opposite sides. A pair, only one. Pair of opposite sides of quadrilateral equal and parallel. So these two are parallel. At the same time, these two are equal also. Okay. So AB is equal to CD and AB is parallel to CD. Then we need to prove. So to prove, so we have to prove here ABCD is a parallelogram. ABCD is parallelogram. We need to prove now. So let's see some. So we need to make one construction because we need two triangles to prove congruent. So we need the concept of congruency only. We'll prove this construction. So I'm doing one construction here. Just join A and C. So diagonal construction here. So join A to C. Then ABC is a triangle and ADC is another triangle. So construction is join A and C. So vertex A and C are joined. So AC is a diagonal. Okay, when we see the proof from ABC and CDA. Okay, ABC and ADC. From triangle ABC and the triangle ADC. So from these two triangles we have to prove first congruent. So to prove congruent we can take one of the any one axiom. So here AB is equals to DC. First we will write the given data. From the given AB is equals to DC, right? So AB is equals to DC. This is the given data. And AC is equals to CA. So it's a common side. AC is equals to CA. And this is the common. So common side for both. And angle BAC. So whenever two line segments are parallel and one is transversal, here this angle, and you can observe here these two angles are equal. So BAC and ACD, these two are equal angles because alternate angles. So AB is parallel to DC and CA is a transversal. Okay, AB is parallel to DC and CA is a transversal. Therefore, we can write angle BAC is equals to DCA. So this is for alternate angles. So alternate angles. As AB is parallel to DC and CA is a transversal, right? Therefore, then we can say according to this SAS axiom, two sides, one angle. So common side and given sides are equal and common angle. Therefore, triangle ABC is congruent to triangle CDA, right? So this is a SAS axiom. So according to the SAS axiom, these two triangles are congruent. Then by CPCT, whenever two triangles are congruent and angle BCA, we can conclude that these we can take another pair. So here, yes, this angle and these two angles, then mark the blue, BCA and CAD are equal. I am taking because ABC is congruent to CDA. So I can write angle BCA is equals to angle DAC. Right? This is a CPCT. Okay, corresponding parts of congruent triangle. But these are alternate interior angles, right? So these two are alternate interior angles. If these two angles are equal, then indirectly AD is parallel to BC. Okay, these two angles are equal and AC is transversal. So obviously AD is parallel to BC. Therefore, AD is parallel to BC because these are alternate interior angles. Then we can say, so already given data, now given values are AB is parallel to DC. This one pair is given and we got just now AD is parallel to BC. So opposite sides are parallel, hence we can conclude that ABCD is a parallelogram. ABCD is a parallelogram. We can confirm that because AB is parallel to DC is given and AD is parallel to BC. So opposite sides are parallel. Therefore, then this also AD is parallel to BC. Then when opposite sides are parallel, then it's a parallelogram, right? So we can say that. And the diagonals of rectangle are equal, then they bisect each other. So one more theorem I will prove. This is for parallelogram. So next I'll explain you some other theorem about diagonals in rectangle. So let's see that also now. The diagonals of a rectangle are equal and bisect each other. So this theorem we need to prove diagonals of rectangle are equal. At the same time they will bisect each other also. So let me take a rectangle. So a rectangle is a type of parallelogram, right? So you can use the rules of parallelogram also here. So diagonals of rectangle are equal, we need to prove. So first of all, the given values, given data here. ABCD is a rectangle and ACBD are the diagonals. So that means if we take ABCD, yeah. So AC and BD are the diagonals. ABCD is rectangle and ACBD are the diagonals. Yes, so this is a given. So we need to prove. So to prove, so the theorems we need to prove according to theorem diagonals of rectangle are equal. So diagonals are here AC and BD. So AC you should prove equals to BD, and they bisect each other. So bisect each other means at the same time I need to prove. So I should take the diagonals bisecting. So that is A to C is one diagonal and D to B is another diagonal. So they are intersected O. So they bisect each other. That means we need to prove OA is equals to OC, and other diagonal is OB is equals to OD. Right? These two also I need to prove. So according to theorem. So you don't have any construction, you can start the proof. So before starting proof, we need to take two triangles. So to prove AC is equals to BD. So AC is one of the diagonal and BD is one of the diagonal. These two diagonals should come in do different triangles. So in triangle, I am taking triangles ABC and triangle. So in ABC, AC is the diagonal. AC is the diagonal part, and in ABD, so you can see here ABD triangle. So from these both we have. So we need to prove these two triangles are congruent first. Okay. So ABC. In ABC, this is the diagonal part, and DBA or ABD. In ABD, so BD is the diagonal part. These two triangles, if I prove congruent, then according to CPCT, I can conclude that AC is equals to BD. Right. So we'll take properties. That is BC is equals to, because in from ABC triangle BC is equals to AD, because BC and AD are the opposite sides of a rectangle. So they are opposite sides of a rectangle, right? So they are equal, and angle B and D also. Angle B means angle ABC. So angle ABC is equals to, at the same time, angle BAD. These two are equal because each angle is equals to 90 degrees. So they are equals to 90, each and every angle. And there is one common side also. AB is the common side for both. And AB is equals to BA. So this is the common side. Right? Now if you observe the side, angle and side. Therefore triangle ABC is congruent to triangle BAD. So this is the angle side angle axiom. two angles. So common side opposite. No, it's SES. Okay, axiom. SES property. Therefore, when two triangles are congruent, that is ABC and BAD. So in ABC, AC and BAD is BD. These two are the diagonals. Then we can conclude that hence AC is equals to BD. This is by CPCT. Corresponding parts of congruent triangle are equal, right? Corresponding parts of congruent triangle is a congruent. And we need to prove this intersecting. That is, they will bisect each other. Means we need to prove AO is equals to OC and OD is equals to OB. So for proof of this, you can write this statement directly. That is, a triangle is a type of parallelogram because a rectangle is a type of a parallelogram. So we know that in parallelogram diagonals bisect each other. So diagonals of rectangle also bisect each other. Okay, in parallelogram diagonals bisect each other, in rectangle also diagonals will bisect each other. That statement we should write. Then we can conclude. Hence OA is equals to OC and OB is equals to OD. Because parallelogram diagonals bisect each other. Hence, so diagonals of rectangle also bisect each other. Then OA is equals to OC and OD is equals to OB. Right? This way you can prove the diagonals of rectangle are equal. So any type of proof in this quadrilateral, you need to test check which two triangles to take to prove they are congruent or not. That's important. Similarly, we can prove the diagonals of square also equal and bisect each other at right angles. So that also I explain in next theorem. How to prove the diagonals of square are equal. The diagonals of square are equal and bisect each other at right angles. Okay, to prove this theorem, so first we should take the given information, right? So simple. So here given data is diagonals of square. That means one square you should take. So I am taking ABCD. Yeah, this is a square. ABCD. A square ABCD whose diagonals AC and BD intersect O. That is a given. So from the statement, ABCD is a square and joining of opposite vertices, that is AC and BD. AC, BD are the diagonals. Fine. So we need to prove diagonals of square are equal first, and we'll see the bisect each other at right angles also. So to prove okay, let me take the diagonal AC and BD. We should prove these both are same. So similarly, same how we did in rectangle, we'll take the two triangles. To take the triangles to prove. So I need to prove here that is AC is equals to BD and AC is perpendicular to BD also because they diagonals bisect each other at right angles. That is AC is perpendicular to BD, and if they intersect at O, we should prove O is the center point. That means OA is equals to OC and OD is equals to OB also we need to prove. Okay, in the proof, take the two triangles from triangle. So every triangle, one of the diagonal. So AC and BD should come. So AC will come from triangle ABC. Okay, from ABC. So AC is the diagonal again from triangle other one, that is BAD. In BAD, the BD diagonal is there. So from these both we have. So what do you have? So AB is equals to BA. So that is the common side, right? This is a common, because we need to prove this both triangles are congruent by any one of the axiom we need to prove. And BC is equals to AD. So here BC and AD, because BC and AD are opposite sides. So opposite sides in a square are equal. So all the sides are equal. So opposite sides also equal in that. And angle, each angle is 90 degrees. So we can take angle ABC. So one angle, and BAD is angle. So two angles. This is equals to 90 degrees. It's the angle, and this is sides of square. So property. Sides of square is BC is equals to AD, and every angle is equal to 90 degrees. So two sides and one angle. Then using this both, therefore two triangles. The triangle ABC is congruent to triangle BAD, right? That is SAS axiom. So side, angle, side. Two sides, common side, sides of the square, and angle I prove. So based on this axiom, these two triangles are congruent. Once two triangles are congruent by CPCT, so hence I can prove AC is equals to BD, because AC is one of the side in ABC triangle and BDC is other. So diagonals are equal. That is CPCT. Corresponding parts of congruent triangle are congruency. And to prove this bisecting each other, to prove only bisect each other, because every square is a type of parallelogram, right? So again, parallelogram diagonals will bisect each other. Similarly, square of diagonals also bisect each other. That is a simple thing. And to prove they bisect each other at right angles, to prove right angles, we should take two triangles. That is, take triangle AOB and triangle AOD, and another triangle is AOD. These two triangles I need to prove congruent. That is, OB is equals to OD, because they bisect. Because every square is a type of parallelogram. Parallelogram diagonals bisect each other. So OB is equals to OD. I am writing here. OB is equals to OD is one side, and OA is equals to AO. It's a common side for both triangles, and AB is equals to AD. So this is the every side. So side of the square. Side, side, side. So triple S. Side, side axiom. Side and side, side. Axiom according to that these two triangles are congruent. That means AOB and AOD, right? So just provide it there. Therefore, triangle AOB is congruent to triangle AOD. That is according to this SAS triple S axiom. Hence, these two are equal. Then by CPCT, angle AOB is equals to angle AOD. Right? We can conclude this. Once these two triangles are congruent, then this is angle AOB. So this angle and angle AOD, these two angles are equal. So we can this. So this angle AOD and AOB are equal. So when, but again this angle of straight line is 180 degrees, right? That means we can take BOD, that is AOB. These both are equal. So AOB and AOD, these both are equal and total angle is 180. So each one should be equal to 90 degrees. Thus, so we can conclude that AO is perpendicular to BD. That is, AC is perpendicular to BD. So when AO is perpendicular to BD, so when this AO is perpendicular to BD, then obviously AC is also perpendicular to BD. So they will bisect each other at right angles. So this way you can conclude the diagonals of square are equal and bisect each other at right angles. So these two triangles you should take. So this way you can prove this. At the same time, we will show you diagonals of rhombus also bisect each other at right angles. So the diagonals of rhombus bisect each other at right angles. To solve this theorem, so we need to take one rhombus. We have to prove when two diagonals intersect each other, that in that place they form a right angles. So let me show you the diagram. So let's take one rhombus. Yes. So all the sides are equal in rhombus and opposite sides are parallel. In this diagonals of rhombus bisect each other, I need to prove. So if you take the letters A, B, C, D are the four vertices and diagonals is AC and BD. So draw the diagonal. So A to C is one diagonal and B to D is another diagonal. They intersect at the point O. Yeah. So according to this theorem, we need to prove OA is equals to OC and OB is equals to OD. At the same time, angle of AOB. So this angle and angle of COB. Any two angles, two adjacent angles inside, we need to prove 90 degrees. Okay. So your first given the information is ABCD is a rhombus. Okay, ABCD is rhombus and ACBD are diagonals. These two are the diagonals, right? And we need to prove here to prove. So what we require to prove, diagonals bisect each other at right angles. So I have to prove that OA is equals to OC and OB is equals to OD. And again the angles, that is angle AOB is equals to angle COB, that is equals to 90 degrees. Okay, the both angles equal to 90. We have to prove. Then let's start the theorem. So when you take the proof, so I have to take two triangles in this. So AOB and OCB. These two triangles, if I prove congruent, these two triangles is congruent, then we can say that OA is equals to OC. So I have to take in triangle AOB. So any type of this theorems, we need to take the particular triangles. So which triangle, if you take the diagonal, they bisect each other, you can prove that triangle should take. So AOB and BOC. From these two triangles, one of the axiom we need to prove. So here alternate angles are there, like OAB, this angle and OCD. These two angles are same. So OAB and OCD. So we will take OCD, opposite to triangles, not BOC. Yeah. So triangle OCD. Now angle A, this is BOA and OCD is equal because AB is parallel to CD and AC is a transversal. So alternate angles. So from triangle AOB and COD, the triangle A means that is BAO. BAO angle is equals to OCD. These two angles are equal. You can see, right? So this is one angle and these two angles. These two are equal because of alternate angles. So alternate angles. Yes. Again OBA. This part and this corner. So you can change the color. You can see here this angle and this. These two are equal because BD is transversal and other two are parallel lines, like ADBC is parallel and BD is transversal. So these two angles are equal. So that we can denote as OBA. OBA is equals to ODC. Yeah. These also same alternate angles, and AB is equal to CD because of opposite sides. AB is equal to CD are equal. So sides of rhombus, because sides of rhombus are equal. Yes, two angles and one side. Then according to two angles one side means ASA axiom. Therefore triangle A, these two triangles OAB, OAB. Here we have taken AOB or OAB. Okay, anything is same triangle. So this triangle and this opposite triangle, these two are congruent now. So AOB at the same time triangle OCD. Yeah, these two are congruent because of ASA axiom. Two angles and one side. Once two triangles are congruent, then corresponding sides are equal. Then you can say OA is equals to OC, and similarly OB is equals to OD also. That is CPCT. Okay, corresponding parts of a congruent triangle rule. Once these two triangles are equal, then we can. This is the bisect each other. Now bisected right angles also we need to prove. So this is simple. Similarly, OAB and OCB. So two adjacent triangles we need to prove congruent. So in this triangle and this side, so AOB and COB, these two triangles if I prove congruent, then these two angles must be equal. Because of straight line they are 180, each angle is 90 degrees. So simple. So this and these two triangles. So I am writing here triangle AOB and triangle BOC. These two triangles are congruent because AB is equals to BC and at the same time two angles. So that two triangles I need to prove congruent. Second eight steps here you can see from diagram. That is again in triangles OAB and OCB. So we can take the, yes, this is again I had taken to show clearly, that is A, B, C, D. So if AC is the diagonal and BD is another diagonal, this is center. These two triangles I need to prove congruent. That is OA is equals to, because already we proved, OA is equals to OC, that is side, and AB is equals to CB. So that is the side of the rhombus. Again OB is equals to OB because it's a common side. So this is the already proved. This is sides of the rhombus and the common side. Then we can say these two triangles. So triangle AOB is congruent to triangle COB. Once these two triangles are congruent, then these two angles are equal. These two angles are equal. That is AOB. So AOB is equals to BOC. But we know that AOB plus BOC is equals to 180 degrees because of the straight line. So angle of the straight line is 180 degrees. So this is completely 180. Now individually same. So indirectly each and every angle is 90 degrees. Therefore angle AOB is equals to angle COB, that is equals to 90 degrees. because both angles sum is 180, every angle is same means each angle is 180 divided by 2. So half of the 180 is 90 degrees. Fine. So in this way you can prove. This is to prove right angle, the intersected right angle, and this to bisect each other. So you can prove this in this way. And I'll show you some one more theorem as well as some problems based on this quadrilateral topic. Bisectors of the angles of a parallelogram enclose a rectangle. So to prove this, so I have taken one parallelogram. So let me keep the points. The vertex A, B, C and D. So this statement says bisectors of angles. So angle A, B, C, D. Angle A is bisected and angle B, angle C and angle D. If you bisect, it encloses a rectangle. So inside, right, this one you have to prove rectangle. That is, take so P, Q, R and S. So we need to prove PQRS is a rectangle and ABCD is parallelogram. Angle ABCD are bisected. So every angle is bisected with this. So AS is, that means these two angles are same, right? These two angles are equal. That is DAP and BAP. If it is P, so PAB and PAD. These two angles are same. Similarly, these two angles. So every vertex has two angles. We have to prove PQRS is a rectangle. To prove PQRS is a rectangle, every angle is 90 degree. If I prove, it's enough. This is a PQRS is a rectangle. So let's start. So here ABCD is a parallelogram. ABCD is parallelogram and ASBS. So these are all AS and CQ. So let's take AS. Is bisector of angle A. AS and B, AS and BS, and next to CQ and DQ. These four are bisectors are these four, the bisectors of continuously angle A, B, C and angle D, right? So here AB is parallel to DC, since we need to prove finally PQRS is a rectangle. So every angle I should prove 90 degrees. For that I am taking, since DC is parallel to AB, so one pair is opposite side is parallel, and DA cuts them, we have so angle A plus D. DA is parallel to AB and AD is a transversal, right? AB is parallel to DC and this AD is transversal. Then we can write angle A plus angle D is equals to 180 degrees. We know that because they are co-interior angles. So at sum of the adjacent angles in a parallelogram are 180. That is the rule. Therefore angle A plus D is 180 degrees. Then angle A is plus D is 180. Then we can half of the A, because angle A is bisected. That means half of the angle A plus half of the angle D is obviously equals to 90 degrees, because A plus D is 180, then half of the A plus half of the D is a 90. So half of the A means I can take, here is, so PAD, that's angle PAD, plus and half of the D is taking this angle, that is PDA or ADP. ADP. These two angles is 90 degrees. Sum of this. So if you can take this later, these two angles, this one plus these two, right? So PAD and ADP, these two is 90. So from APD triangle, once these two angles are 90 degrees, sum of these two are 90, then third one should be equal to 90, because sum of the angles in a triangle is 180 degrees. So using this concept, we can take angle APD, but PAD plus ADP plus and angle P, that is APD. Sum of these three angles is 180 degrees, but already these two is 190. Okay, here these two angles is 90 degrees plus angle APD is equals to 180. Then therefore angle APD is equals to 90 degrees. 180 minus 90 is 90. So finally we got angle APD is 90 degrees. So observe here. Now this is 90. If it is 90, then opposite angle, vertically opposite angles, right? So you can see this is 90 degrees and vertically opposite angles also must be 90. That means QPS. Yeah, this is Q. Therefore QPS is 90 degrees inside angle. So this is also 90 degrees. This is SPQ, or yeah, that PSPQ angle. Then SPQ is 90 degrees because vertically opposite. So vertically opposite angles. So one angle I got 90 degrees by taking this. Similarly, we can prove angle SRQ is 90 and this is 90 and the other three also 90 we can prove. For remaining three also is 90, 90 we get. So similarly, one of the angle you have to prove 90 degrees first inside the rectangle. Then you can write similarly angle PQR is 90 degrees and QRS because inside the rectangle is all other three angles, and PSR is also 90 degrees. Thus we can conclude that PQRS is a quadrilateral because every angle is 90 degrees. PQRS is quadrilateral, each of whose angle is 90 degrees. Is quadrilateral and each of whose angle is 90 degrees. So any quadrilateral every angle is 90, then you can conclude hence PQRS is a rectangle. So only till we can do this step and similarly write, then we can conclude that other three angles also 90. Similarly we can prove same, if we take half of the A plus half of the B, this is 90 will come, and half of the C plus half of the B is 90 and the remaining is 90 will come, opposite also 90. So similarly other three angles also 90 degrees each. So this way you can prove the bisectors of angles of a parallelogram enclose a rectangle. And similarly we can write this. Then I will show you some numerical problems which are related to this quadrilateral. How the questions will come based on these theorems and properties. I'll show you some problems now. Problems based on this quadrilateral. Let us see. Problems based on quadrilaterals. So let us see how the questions will come from this topic, from this class. So let me explain you some problems and you can find the other sums also related along with this. So when you see, okay, one question I'll explain. Few problems you'll see based on these quadrilaterals. So question is, in a parallelogram, ABCD, if angle A is equals to 115 degrees, then find other angles. So that means angle B, C and D. Other angles we need to find out. So if we take the parallelogram, we should know properties of the parallelograms. Whatever the question is asking, we should know the properties of the particular quadrilateral. If the question is about parallelogram, right? So we should know the properties of parallelogram. So if you any two lines are parallel here. So AB, CD. AB is parallel to CD. So these two are parallel, and other two sides, opposite sides, are parallel and equal. Then according to the rule, sum of the adjacent angles is 180 degrees. That means angle A plus angle D. Both are 180 degrees. So angle A is 115 degrees is given. Now angle B. Sum of the adjacent angles. Angle A and D is adjacent and AB also adjacent. So if we take AB is X, we can find out. So according to this property, angle A plus angle B is equals to 180 degrees because co-interior angles. So always sum of the adjacent angles, co-interior angles. Angle A is 115 degree plus angle B I took as X. So 180 degrees. Then X is equals to 180 minus 150. So 180 minus 115 is 65. Angle X is 65. That means angle B is 65. Therefore, angle B is equals to 65 degrees. And since the opposite angles of parallelogram are equal, and there is also property. So in a parallelogram, opposite angles are equal. So angle A is opposite to angle C. That means angle A is equals to angle C. Angle A is 115 degree. So angle C also 115. And angle B is equals to angle D. But angle B we got 65 degree. Therefore angle D also 65 degrees. So this way. So we should know some properties. Then we can find out the problems easily. So let me show you one more sum. Okay. This is about, okay, I'll take one question about rectangle. So in a rectangle, let me draw the rectangle. In a rectangle. So immediately you should know the properties of rectangle. So rectangle is opposite sides are equal and every angle is also 90 degrees and two diagonals. So two diagonals. Okay, let me write the question first. ABCD is a rectangle and diagonals are intersected to angle OAB. This angle is 32 degrees. Then find out angle ACB. Then find from the adjoining figure, find angle ACB. ACB we need to find out, and angle OBC. OBC. These two angles we need to find out. So let's take angle ACB. So ACB is here. This is, I'm taking X. So you need to do this first part. Sum of the angles in a triangle is 180 degrees and angle B is, the total angle B is 90 degrees because every angle in a rectangle is 90. So this is 90. Now from triangle, so what you can take from triangle ABC, so 32 degrees angle BAC plus 90 degrees plus angle, what you have to find out, that is ACB, I took X. Okay. Let angle ACB is equals to X. X means that is 180 degrees. Sum of the three angles in a triangle is 180 degree. Then we can find out X value easily. 32 plus 90, that is 122 plus X is equals to 180. Then X is equals to 180 minus 122. That's 58 degree. So angle X is 58. So X is your angle ACB, that is equals to 58 degree. That's it. And one more is angle OBC. OBC. Only this part I need to find out separately. This angle is taken as Y. So we know that OA is equals to OB. Okay, these two sides are same. So whenever two sides are equal in triangle, it's the isosceles triangle, then opposite angles also equal, right? From triangle AOB, so observe here, AOB, OA is equals to OB. Then this angle if it is 32 and this angle also should be 32. Then we can write this is also 32 degrees. Then total angle is 90. So y plus 32 is equal to 90. So to prove second one, y plus 32 is equals to 90 degrees. Then y is equals to 90 minus 32. 90 minus 32 is again 58. It's 58 you can write. That is angle OBC. OBC is equals to 58 degree. There are many ways you can prove. Even if you take from triangle OCB and this OC is equals to OB, then opposite angles are equal. So x is equal to y. Also we can do. So you should know the properties to prove the particular angle which is asked, right? And see one more sum. So in the adjoint figure, okay, ABC is a rhombus. I'll take one rhombus diagram. ABCD. ABCD is the rhombus and BD is the diagonal. B to D. BD is diagonal. Angle A is given. So angle A is equals to 70 degree. So from adjoint figure ABCD is rhombus if angle A is equals to 70 degree, right? Find angle CDB. Find angle CDB. So CDB is this angle. So take some letter X. We know that angle C is equals to A because in rhombus opposite angles are equal. So there is a property, that is angle A is equals to angle C because opposite angles in a rhombus they are equal. Then we can say that is equals to 70 degrees. Therefore angle C also 70 degree. Then okay, if you take this as 70 opposite angles. Now observe from triangle BDC, BC is equals to CD because whenever these two sides are equal, then opposite angles also equal. So this also should be X. That is CBD. Angle CBD is equals to angle CDP. These both are equal, I took it as X. That's it. Now from the same triangle, sum of the angles in a triangle is 180 degrees. Now using that concept, x plus 70 is equals to 180 degrees. X plus x is 2x is equals to 180 minus 70. So 2x is equals to 110. Then you can find out x value is 110 divided by 2. X is equals to 55 degrees. So x is nothing but angle CDB. Therefore angle CDB is 55 degree. Yes. So only we need to apply the properties. And we'll see one word problem. So this is in quadrilateral word problems will come. Let me show you. So write the question. The length of the diagonals in quadrilateral one word problem. The length of the diagonals of a rhombus are 24 centimeters and 18 centimeters respectively. Then we need to find the length of each side of the rhombus. Okay, so this is the given question. So it's very simple. The length of the diagonals of rhombus are given. That is 24 and 18. We need to find out the length of each side of the rhombus. So if we observe the rhombus properties, every side is equal, right? So this is the rhombus. So they have given diagonals. I'm taking letter vertex A, B, C, D, and two diagonals. Length of the diagonals are given B, D. So B to D is 24 and AC is 18, and they were intersected O. So if you observe the properties of rhombus, diagonals in the rhombus are, they bisect each other at right angles. That means angle DOC is 90 degrees, and they will bisect also. In this question, BD is equals to 24 centimeters. This is given, and AC is equals to 18 centimeters. BD is nothing but BO plus OD, right? So OD, O to D distance is half of the BD, because O is the midpoint of total diagonal. O is the center point because they intersect. In rhombus, diagonals are intersecting each other. So half of BD is 24, 2 ones are 2 12s, so 12 centimeters. Then OD is equals to 12 centimeters. And AC is 18. Then OC is equals to half of the AC, because O is the midpoint for AC also. Then OC is half into 18. 1 by 2 into 18 is 9. So 9 centimeters is OC. Now if you measure and keep the values here, OD is 12 centimeters and OC is 9 centimeters. Let CD is X. Now this is a right angle triangle. If you apply the Pythagoras theorem, so the length of each side of the rhombus is X, and right angle triangle, so this from OCD triangle, according to the Pythagoras theorem, hypotenuse square is X square is equal to sum of the squares of other two sides, that is 12 square plus 9 square. This is by Pythagoras theorem. So Pythagorean theorem from triangle OCD, because OCD is the hypotenuse. This you have to simplify to get the value of X. 12 square 144 plus 9 square is 81. 144 plus 81 is 225 is the value of X square. Then X is equal to square root of 225. Square root of 225 is 15 centimeters. Hence, yes, X is equal to side of the rhombus. So every side is equal in the rhombus. Therefore, the length of each side of the rhombus is equals to 15 centimeters. So this is the one. Therefore, CD. Now every side is same. This is 15 centimeters, and this also 15. BC is 15 because of X is equals to 15 centimeters. So every side in rhombus is equal. Yes. So this way we can solve the numerical problems. Only we should know the properties thoroughly. So like previous topics what I explained. So each and everything like parallelogram, rhombus, square, rectangle, kite, trapezium. These all the properties if you know. Then problems are easily we can solve. So any type of questions that is coming, we can do these word problems. Okay, these are all the topics including So not only these few sums, so other questions also I showed earlier in this website. So you can see, right? So in this website you can find out the number of worksheets and different questions solutions. At the same time, you can find the assignments also, including previous papers for all the subjects are available for freely. You can download and can go through. And subscribe the channel and share with your friends because we'll upload only the videos which are related to education. It's helpful for you and as well as for us.